Guys to my YouTube channel. Okay, you are welcome to my YouTube channel today. We are going to take the revelation hour of our physics part 2. And in today's video lesson, we are going to be looking at two important resistors in DC circuit. And these resistors are one, shunt, while the other is what? Multiplier. Now I want you to take note of this important topic because it's a very interesting topic and you are likely to see it in your JAM exam. Now, what are shunts and multipliers? Your shunts and multipliers are resistors used to convert your galvanometer to an ammeter or your voltmeter. Remember that electric circuit elements are, for instance, we'll talk about galvanometer. A galvanometer is a device that is used to detect or measure very small current. It is used to detect very small current. That's the function of a galvanometer. A galvanometer is also called a milliammeter. That is to say, your galvanometer is a special type of ammeter that is basically used to detect small amounts of what? Current. That's what a galvanometer is meant for. Galvanometer is used to measure very small amounts of current. And your galvanometer is said to be sensitive if it is able to detect slight change in current. Okay? Now again, we have another circuit element called the ammeter. What is an ammeter? An ammeter is a device that is used to measure current. But a galvanometer is basically used to measure small current. So you can see that while your ammeter is based on current alone, your galvanometer is for small current. That is to say, your galvanometer is a special type of ammeter. That is why we call galvanometer milliammeter. Please take note of that. Your milliammeter is the same with your word galvanometer. So galvanometer is to measure small current, while ammeter measures current, whether small or big current. Then again, what is a voltmeter? A voltmeter is a device that is used to measure voltage. So we have three important circuit elements under this subtopic called shunt and multiplier. And in this video lesson, we are first of all going to take on how to convert a galvanometer to an ammeter. Remember, galvanometer is meant for small current, but ammeter is meant for both small and big current. So that is to say, you can make your galvanometer to function like an ammeter by doing what? Now, if you want your galvanometer to function like an ammeter, you simply do this. What do you have to do? You have to do what? A galvanometer can be converted to an ammeter by connecting a suitable resistor of low resistance called what? Shunt. That's why we have the heading shunt, okay? In parallel with the galvanometer. Wow, that's interesting. That is to say, I can turn my galvanometer into an ammeter by just connecting your shunt with the galvanometer in parallel. So the circuit diagram you have on the board is a parallel connection of your galvanometer and your shunt. This shunt enables the galvanometer to behave like an ammeter. That is to say, with the help of this low resistor called shunt, this galvanometer will be able to measure large amounts of current. So to do this, the shunt must be in parallel with the galvanometer. Now this is how it works. Remember, the total current that is to be measured is called I total. This total current here, we'll call it I total. As the current comes this way, when it gets to this junction, some of the current will enter the galvanometer, while some will enter the shunt, so that the large amount of current coming will be measured by the combining effort of this galvanometer and the shunt. So at the end of the day, the total current will be measured by both of them. In so doing, this your galvanometer is now functioning like what? An ammeter. Please take note of this. Your galvanometer can be converted to an ammeter by connecting shunt in parallel. Take note. it must be a parallel word connection. And if it's a parallel connection, don't forget that for a parallel connection, the current is not the same. We have Ig here. Your Ig signifies current in the galvanometer. Take note of that. Current in the galvanometer. Okay? Then your arrow G in this diagram signify what? Resistance of the galvanometer. So take note of this. We have current through the galvanometer and we have the internal resistance of the word galvanometer. What about your IS? Your IS means what? Current in the shunt. This is the resistor of low resistance. Okay? Then your ROS means resistance of the shunt. So please take note of that. It means that whenever you are to convert a galvanometer to an ammeter, you must take note of this important connection. They must be in parallel. And if two circuit elements are in parallel, it means that the voltage of one circuit element will be the same with the voltage of the other circuit element. Remember from Ohm's law. Remember what Ohm's law says. Ohm's law says that the current flowing through a metallic conductor is directly proportional to the what? Potential difference, provided that the temperature and every other physical parameters are kept constant. So from Ohm's law, we found out that voltage is equal to current times resistance, as you can see. So if I have voltage equals to current times resistance, it means that your voltage in the galvanometer will be what? Current in the galvanometer times resistance of the galvanometer. Take note of that. Voltage is current times resistance. So voltage in the galvanometer will be what? Current in the galvanometer times resistance of the galvanometer. And again, your voltage in the shunt will be current in the shunt times the resistance of the shunt. Take note of that. So we have voltage in the galvanometer and we have voltage in the shunt. Now remember that the connection here is parallel, and if two circuit elements are connected parallel to each other, it means that the voltage that flows in one of the circuit elements will be the same with the voltage that flows in the other circuit element. Therefore, it means that we are going to establish a very important formula that can help us solve problems involving the conversion of galvanometer to what? An ammeter. If you can establish this part that their voltages are the same, it means that, don't forget, if the voltage in galvanometer is equals to the voltage in the shunt, then we have gotten what we are looking for. Now, what is voltage in galvanometer? It is current in galvanometer times what? Resistance in the galvanometer. What is voltage in the shunt? It is what? Current in the shunt times the resistance in the shunt. So this important formula will help us demystify problems involving the conversion of galvanometer to what? An ammeter. Don't forget, we are talking about shunt and multiplier. We are basically on shunt, okay? Take note of this important formula. One other important formula that we need here is this. Remember that the total current coming to the circuit is called I total. And when the current gets to this place, this point here is called a junction. It's called a junction. A junction is a point where three or more circuit elements meet. At this junction, the current will divide. Some current will come here, while some will go here. Please take note of that. It therefore means that the current entering the galvanometer and the current entering the shunt, by the time we add these two currents together, we'll get the total current. And that is what we call the Kirchhoff's first law of current. So according to Kirchhoff's first law of current, we'll discover that the total current, which is your I total, is equals to the current in the word galvanometer plus the current in the shunt. take note of this important formula too. Okay, so we are going to take a question on these subtopics. Thank you. Now let's take this first question on the conversion of galvanometer to an ammeter by using a shunt wire. The first question says a galvanometer of resistance 5 ohms. Now if we want to solve this question, it will be important that we bring out our parameters. The 5 ohm here, as it is stated, means the resistance of the galvanometer. So the resistance of the galvanometer is equals to 5 ohms. This is the resistance of the galvanometer. Has a full scale deflection of 100 milliampere. Like I told you, a galvanometer is also called milliammeter. So the current is measured in milliampere. So this is the current through the galvanometer. So we can say that our IG is 100 milliampere. Please, if you are given the current in milliampere, you must convert to ampere by dividing the value by 1000. So if we do that, we'll divide this one by 1000. And that will give us 0.1 volts ampere. This is the current through the galvanometer. Wow. Now let us continue. How would its range be increased to 1.0 ampere? By placing a resistance of what? Now this 1.0 ampere is the current that is to be measured by the galvanometer. So how do you increase the range of this galvanometer so that it can be able to measure a current of 1 ampere? Remember, you need a resistor of low resistance. First of all, 1.0 ampere is the total current. Okay, so our I total is 1.0 ampere. Okay, now what do we need to do? They said, what will be the value of the resistance that will be converted to this galvanometer so that it can measure that current? You know that the wire must be a shunt wire or shunt resistor. Therefore, we will say that the resistance of the shunt is unknown. So what we need is to calculate for the resistance of the shunt. That's very easy. Now, first of all, remember I gave you a very important formula. I said the voltage in the galvanometer is equal to the voltage in the shunt. Now, if voltage in galvanometer is equal to that of shunt, remember that voltage is Ig. So, I of galvanometer, arrow of galvanometer, which is the voltage, is equals to I of shunt, arrow of shunt. From this important formula, we can get the resistance of the word shunt. Now, do we have Ig, which is the current in the galvanometer? Yes, look at it, 0.1 ampere. Do we have arrow G, which is the resistance of the galvanometer? Yes, which is 5 ohms. Do we have Ix? No. Do we have arrow X? No. We cannot be looking for two things at the same time. If we are looking for arrow X, which is given to us in the option, then we need to know what Is is. How do I know what Is is? Remember the diagram I drew for you. The total current entry is I total. The current will now be shared between galvanometer and shunt. So from this 1 ampere, which is that current, this guy has collected 0.1 ampere. So what will now be the current in the shunt now? Current that will be in the shunt will be total minus the 1 galvanometer has collected. That will now give us 0.9 volts ampere. You see that is very cheap. We have current in the galvanometer already. Total current is 1. So we are looking for the, don't forget we have only galvanometer and shunt. So the total current is 1. If your galvanometer is 0.1, the other current will go to the shunt. So we do 1 minus 0.1 to give us 0.9 ampere. Very easy. Then this formula becomes very important for us to use. What do we need to do? Ig is the current in the word galvanometer, which is 0.1. Resistance of the galvanometer is what? 5. Equals to Ix, which is 0.9 times resistance in the shunt is what? Arrow X. That's very easy. 0.1 times 5, 0.5 equals 0.9 arrow X. So what do we do? Divide both sides by 0.9, divided by 0.9. This one cancel this, so that arrow X, which is the resistance in the shunt, is 0.5 over 0.9. You can cancel these zeros, so you are left with 5 over 9 ohms. So you have to be very careful also because you have 9 over 5 and you have 5 over 9. So you have 5 over 9. Remember that the resistor must be in what? Parallel. If you must convert a galvanometer to an ammeter. So the answer is not A. The answer is not B. The answer is not C. The answer is what? D. Wow, that's very interesting. So we are going to take question number 2. Now let's take question number 2. A galvanometer has a resistance of 5 ohms. Okay? Now the resistance of the galvanometer is equals to 5 ohms. By placing a shunt wire of resistance 0.05 ohm. So the resistance of the shunt is 0.05 ohms. Okay, let's continue. The galvanometer could be converted to an ammeter capable of reading a total current of 2 ampere. So our I total, this is not the current in the galvanometer, neither is it the current in the shunt. This is the total current, okay? So the total current is equals to 2 ampere. Did they give us current in the galvanometer? No. Were we giving current in the shunt? No. So these two guys are unknown. But we know that if I add this one to this one, it will give us the total current. Then I said that what is the current through the word galvanometer? That means we are looking for this. We are not looking for this. Is what we are looking for. Current in the galvanometer. This is quite very cheap. Remember what I told you. The formula still remains the same. That for you to convert a galvanometer to an ammeter, you must connect the shunt in parallel to the galvanometer. And when that is done, the voltage in the galvanometer, G, must be equal to the voltage in the shunt, S. And what is voltage? Every voltage is current times resistance. So it will be IG, arrow G, equals to IS, arrow X. Very cheap. This is what you need to do. As far as you know that it must be parallel, you have gotten your answer. Did they give us IG? No. This is what we are looking for. Okay, so let's mark that. Did they give us arrow G? Yes. They gave us 5 ohms. Did they give us IS? No. But they give us arrow X? Yes. So if we are looking for the current here, we must need to get the current here. It is very important. This is not what we are looking for, but we need it. Remember that IG plus IS is equals to the total current. And what is the total current? 2 ampere. So let's quickly just do this. What will IS be? Our IX therefore will become, if you take this one here, you have 2 minus IG. So take note of this. This becomes the current in the world, in the shunt. And if that is done, you have gotten your answer. Let's quickly place our values into the formula. First of all, what is IG? It was not given. That's what we are looking for. Times arrow G. Arrow G was given to us as 5. Equals to, what is IS? IS is 2 minus IG. Then, what is arrow X? Arrow X is given to us as 0.05. So IG times 5 will give us 5 IG equals to, let's open this bracket, 0.05 times 2. You have 0.1. 0.05 times IG minus 0.05 IG. So what do we quickly do? We are going to collect like terms. So that 5 IG plus 0.05 IG is equals to 0.1. So if I add this together, I'm likely to get 5.05 IG equals 0.1. So how do I get my current? IG will give us 0.1 divided by 5.05. 5.05. Let's quickly do this. 0.1 divided by 5.05. That will give us 0.01980. Wow. Now let us, because if you check the options, you will see that the options are given either in a whole number. So let's first of all approximate it. 0.0198 can give us 0.02 ampere. This is the current that is flowing in the world galvanometer. But because the options are given in milliammeter, we are going to times this one by 1000. Remember, if it was in milliammeter, you have divided by 1000. So now that it's in ampere, you times by 1000. So let's multiply this by 1000. If this is done, you are going to get times 1000. We are going to get 20 milliampere. So this is the current flowing through the galvanometer. So the answer is not A, it is not B. The answer is word C. Are we together? So we are going to take just one question on multiplier, okay? Now we are going to convert a galvanometer to a voltmeter. We are going to convert a galvanometer to a voltmeter. Remember, we talked about conversion of galvanometer to ammeter. Now we want to talk about conversion of galvanometer to a voltmeter. How do I convert a galvanometer to a voltmeter? Remember, a voltmeter measures voltage, but you can make your galvanometer to measure voltage by just doing this. What do you have to do? Very easy. A galvanometer can be converted to a voltmeter by doing what? By connecting a suitable resistor of high resistance. Take note of that. When the one we did before was low resistance, that's shunt. Shunt is a resistance of low value. Now, by connecting a suitable resistor of high resistance called multiplier in series, not in parallel. For shunt, it is parallel, but for multiplier, it is what? Series. So, please take a look at this diagram. You will see that because these two circuit elements are the same, because they are connected in series, the current that flows here will also enter here. So, the current here and the current here is the same. They are the same because there's no connection here. There's no connection. So you have current here. That's why I labeled it as I and I. So we don't have IG and we don't have IM. The current here and the current here is the same. But you must know, if you know that the current is the same, it becomes very easy for you to do. Remember that voltage is I times R. Therefore, voltage in galvanometer is current in galvanometer times resistance of the galvanometer. And your voltage in the multiplier is what? Current in the multiplier times resistance in the multiplier. What do they have in common? They have the same current. Oh yeah, make current solid formula here. You have IG equals to VG over RG. Oh yeah, do the same here. What do you have? You have IN equals to Vn over Rn. If you can establish this fact, it means that you have gotten anything you are looking for. That's quite very easy. So if Ig and Im is the same, it means that Vg over Rg, which is your Ig, is equals to what? Vn over what? Rn. So this is the formula used. That's very easy. Because why did I do it this way? The current here and the current, so make the current Sodium formula. In the other one, the voltage were the same, so make the Sodium formula and then equate it. And that's all you need to do. Remember, finally, recall that by Kirchhoff's second law, the total voltage is the voltage here plus the voltage here. So V total is equals to Vg plus Vn. This is called voltage in the multiplier. This is called voltage in the galvanometer. And this is called voltage. This is called your total voltage. So if you know these two important formula, it means that you can demystify this problem. Let's quickly solve this particular question. Okay? Let's quickly solve the question. The question says that a maximum permissible current through a galvanometer G of internal resistance 10 ohms. Wow, that means the resistance of the galvanometer ROG is equals to 10 ohms. That is the resistance of the galvanometer. Look at it. Is 0.5 ampere. The maximum permissible current. So the current in the galvanometer is 0.05 ampere. So let's do it. current in the galvanometer is 0.05 ampere. This is the resistance, this is the word current. Wow. A resistance of R is used to convert G into a voltmeter with a maximum reading of 100 volts. That means the total voltage that is to be measured is 100 volts. Wow. If your total voltage V total is 100 volts, did they give us the voltage in the galvanometer? No. Were we given the voltage in the multiplier? No. So what do we do now? Let's quickly do this. We were not given VG, we were not given VM. Now, they told us that into a voltmeter with a maximum reading of 100 volts, that's V total, find the value of R and how it is connected to G. That means find the value of the word resistance in the word multiplier. That is very easy. Why did I say so? Please watch this. Watch this very well. Do you know that voltage is equals to current times your resistance? I can get voltage in the galvanometer by doing RG times ROG. So that means the voltage in the galvanometer will be what? 0.05 times your what? Your 10, and that will give us 0.5 volts. What becomes the voltage in the multiplier? Remember, the total voltage is what? 100. So if the voltage in the galvanometer is 0.5 volts, that means the voltage in the multiplier will be 100 minus 0.5. And that will give us 99.5 voltage. So this is the voltage in the multiplier, this is the voltage in the galvanometer. Remember what I told you, that Vg over ROG is Vm over Rm. So let's use the formula to demystify it. Vg over ROG is Vm over Rom. What is Vg? Voltage in the galvanometer. Did we know it? Yes, 0.5. What is the resistance of the galvanometer? Did they give us? Yes, it is 10. What's the voltage of the multiplier? We have gotten 99.5 all over words Rom. So let's cross multiply. When you cross multiply, you have 0.5 Rom equals to 10 times 99.5. So 0.5 resistance of the multiplier is 995. We divide both sides by 0.5 divided by 0.5. This cancel this. Vote resistance of the multiplier will give us. Let's quickly do this. (995) divided by 0.5. Wow, so we have 1990. 1990 ohms. In what? In series. Whenever you want to convert galvanometer to what? Ammeter, what do? You use a what? A shunt in what? In parallel. Please take note of that. Write it down. Galvanometer to voltmeter. What do? You use a multiplier in what? In series. So in this connection, it must be what? Series. Is it option A? No. Is it option B? No. Is it option C? Yes. This is the answer. Now I'm going to give you one question to take as your assignment. And whatever answer you get should be sent to me in the comment section. Let's quickly take that question. Let me give you a question. So you're going to take this question. A galvanometer with a full-scale deflection of this has a resistance of 50 ohm. Determine the value of the resistor required to convert it to a voltmeter capable of reading a total voltage of 1.5 volts. Please do this as your assignment and send your answer to me in the comment section. If today is your first time for coming across the H2O channel, please do well to subscribe for more. Thank you very much. I'll see you in our next video lesson.